Let's do some mole problems. Number 3, we're supposed to calculate the number of carbon atoms in 0.500 moles of carbon. So first we need to create the equivalency. We know that 1 mole of carbon is equal to 6.022 times 10 to the 23rd atoms of carbon. Now we're starting with 0.500 moles of carbon. So those are the starting units. And we create the conversion factor here. We want 1 mole of carbon to be on the bottom so that, it cancels there. And on top will be our Avogadro's number. Okay. And you can punch this all into your calculator and so on. But I know that 0.5 is 1/2, and this nicely divides into this number here to give you an answer of 3.011 times 10 to the 23rd. Well, let me clean that 3 up a little bit. Atoms of copper. Sorry, carbon. Carbon is capital C. For problem B, we want to know the number of SO2 molecules in 1.28 moles of SO2. So what we need to recognize, once again, is that 1 mole of SO2, okay, is equal to 6.022 times 10 to the 23rd molecules of SO2. So that's a whole bunch. Now, we are starting with this quantity here, 1.28. And the units there are moles of SO2. And we want to create our conversion factor here by putting 1 mole of SO2 on the bottom. Okay, so that cancels. And on top is going to be our Avogadro's number. Okay, and so on your calculator, I'm using a Casio, but I type in 1.28 times 6.022, and then simply hit the EXP button, and then type 23, and then hit the equal key, and that gives me a number. We want to round this off to 3 sig figs, so that's going to be 7.71 times 10 to the 23, and we have to write this whole word out, molecules, and that's sulfur dioxide. Okay, now when you're rounding to 3 sig figs, you only keep these numbers, you don't count the exponential part. And I realized up here this should actually be 3.01 times 10 to the 23rd to have 3 sig figs. Okay. All right. So for problem C, we're doing something similar. We're given, but instead we're given or starting with atoms of iron, and we want to figure out how many moles that is. So first, what we do is, once again, we set up the equal sign, right? The equivalency. 1 mole of iron is equal to a gazillion atoms of iron. Okay. And we're starting with this very large quantity of atoms. Okay. And once again, we create our equivalency, but this time we want the Avogadro's number to be on the bottom. so that the atoms of iron cancels. And on top, we're going to have 1 mole of iron. Okay. Now, on some calculators, you get an answer like 10 to the power 44. So make sure you use parentheses. Try using parentheses if your calculator gives you the wrong answer. So let's type in 5.22 exp22 divide 6.022 exp23. Okay. And the answer that you should get here on your calculator is 0. And we want 3 sig figs here, 0.0867. Okay, and the units there are going to be in units of mole. Okay, mole of iron. Okay, so let's look at problem D. We're given we're given molecules, this gazillion molecules of this formula C2H6O, and we're asked to calculate moles. So once again, you carefully write down your equivalency. We know that 1 mole of this chemical formula C2H6O is going to be equal to this very large quantity of individual atoms. Okay. This could be one of several things, but I believe this formula is for ethanol. All right, so now what we do is we repeat the process. We write down the starting units here in the word from the word problem, 8.50 times 10 to the 24, okay? And we want, oops, I'm not using units, so that would be confusing. We have molecules of C2H6O, all right? We want, in order for the units to cancel, Avogadro's number to be on the bottom. Unfortunately, there's no abbreviation for molecules. And on top, we have 1 mole of C2H6O. Now, the molecules of substance cancels. And on our calculator, again, so if you have a calculator that gives you the wrong answer, try re-punching it in with parentheses, okay? And I'm going to type 8.5 exp24 divide 6.022 exp23, okay? Your calculator might have an EXP or an EE button, and that's the best way to type in these. We want to round this to 3 sig figs, so this is going to be 14.1 moles of C2H6O. All right, so that's how you do some basic mole to particle or particle to mole conversions. Thanks for watching, and please subscribe.